Yep, that video started a while ago. All right, so good job, Orion. Okay, so back to this. Okay. All right, so guys, like I was saying a minute ago, angle of depression. If you understand angle of elevation, angle of depression, or also known as angle of descent, is not going to create a problem or an issue. It's the same thing. It's still in relation to a horizontal line, but now it's the angle that rotates downward. So, again, the weird thing about example number 3 is the way that the sketch is going to go. Again, I'm not a swimmer or anything, but I don't think that most pools are built this way. But we're gonna go with the way that it says. It says the swimming pool is 20 meters long and 12 meters wide. The bottom of the pool is slanted so that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. We want to find the angle of depression of the bottom of the pool. So the way that I understand it, usually swimming pool is probably going to go flat for a while, and then it's going to descend down, and then it's going to be flat. So then you have the shallow end, and then you have the deep end. That's not what we have going on in this problem. In this problem, it looks like we started here, and then we're immediately descending down to the deep end. Like I said, a little abnormal, I would suppose. All right, so back to this. We are told that the swimming pool is 20 meters long. It's 12 meters wide. Do we care about that? Not at all. Not at all. We're also told that the shallow end is 1.3 meters and the deep end is 4 meters. Okay, so we're trying to figure out the angle of depression. So we just sketched this up. Is this going to be my angle of depression right here? It is not. How do I know that that is not the angle of depression? Is it? I was going to say, is it in relation to a horizontal line? It's not. It's being formed. That diagonal is being formed with a vertical line. So no, that is not the angle of depression. Rid of that. So what I would encourage you to do, I would say that this is the key point. That's where our descent begins, right? What if we had a horizontal line that continued through that point? First question that I have for you, is that measurement going to be equivalent to this measurement over here? Should be, so that's still going to be 1.3. We knew that the entire deep end was 4 meters. Is that enough for us to figure out what this piece over here is going to be? What's that going to subtract out to be? 2.7. 2.7 meters. All right, so if now we're looking at the red triangle, now do we pretty clearly have an angle of descent? Yeah, so just looking at the red triangle, we've got 20 as the adjacent, we have 2.7 as the opposite, and we have theta marked. If I have the opposite and the adjacent, I'm trying to find the angle. Which trig function am I going to set up? So the tangent of theta is equal to the opposite 2.7 over the adjacent 20. I always forget. How do I get rid of the tangent? Apply the tangent inverse. Do it on the left, we have to do it on the right. So here the cancellation occurs. Theta is equal to the tangent inverse of 2.7 over 20. What is theta, please? You're going to want to check your mode. Check your mode. What was it? 7.69 was what I had. I don't know. You guys saying 6.8? Yeah. 7.68. But what is that, though? It's going to be in degrees. Read the problem, guys. We're finding an angle. So 7.68 degrees. That degree sign, is that optional? That is not optional. We're aware that if we would not have written up that degree symbol, we'd have to assume that we meant 7.68 radians, which is very, very wrong. You're right. It's wrong. All right. So moving on. Next one. This problem, this was actually one that, the only one, in fact, that was not pulled directly from an ACT practice guide or actual retired test. This is one that Miss Bender, this is actually her kid, flying a kite, I don't know how many years ago, but again, she took this picture, and I know that that's pretty difficult to see. But again, this is a key type of problem. So here's ground level. Let's try and redraw this sketch. So there's the kid flying the kite, and we're going to try to do some stuff here. So it says that we want to find the height of the kite if all 50 feet of the string are out. So that's going to be 50 feet. The height of the boy's hand is 3 feet off of the ground, and the angle of elevation is 34 degrees. All right, so what that means is that if the boy's hand is 3 feet off the ground, can I draw my right triangle here? Yes. If this is a 34-degree angle, could I solve for x? Also, yes. X is the opposite of the 34-degree angle. 50 is the hypotenuse, so opposite hypotenuse. What's my trig function? So the sine of 34 degrees is equal to the opposite over the hypotenuse. We're going to multiply both sides here by 50, so x is going to be 50 times the sine of 34 degrees. What do I get there, please? 27.96 or something like that?
Yeah, that's right.
27.96 feet. All right, so guys, like we said, we're trying to prepare for the ACT just as much as we are trying to prepare for the Chapter 4 test. In both cases, ACT would probably be a multiple choice question. Not probably, it would be on ACT, whereas Chapter 4 test would not be, most likely. But if we're to think about the ACT and they had this exact same question, do you think that 27.96 would have been one of the answer choices? Absolutely. It'd be wrong, wouldn't it? Why? Yeah. No, it's in feet. So think about it. 27.96 feet, that represents the verticality that the height is. How high vertically is the kite above the boy's hand? Well, the boy's hand isn't on the ground level. What did it say? The ground level compared to the boy's hand, he's 3 feet off the ground, isn't he? So if we determine that the kite is 27.96 feet above the boy's hand, don't we have to add 3 feet to figure out how high the kite is off the ground? So the final answer is going to be 30.96 feet. So we're going to talk about this a lot, that ACT on many questions is literally trying to trick you. Like they are trying to bait you into doing things the wrong way. I don't like that very much, but that's the game that we have to play here, right? Okay, we just have to be prepared for it and beat it anyway. All right, so we've done already a ladder problem. Let's go ahead and hit another one real fast. These ladder problems, it's like an ACT or really Pythagorean theorem or right triangle go-to. It says the ladder's 10 feet long, leans against the side of a house. All right, there's the house, there's the ground, here's my ladder, it's 10 feet. We want to find the height from the top of the ladder to the ground, so from here to the ground, if the angle of elevation is 69 degrees. So, virtually identical to the problem that we did previously with the 110-foot ladder, just on a smaller scale. Opposite hypotenuse, we agreed that the sine of 69 degrees is equal to x over 10. So 10 times the sine of 69 degrees should get us there. What are we going to say? X is 9.34 feet. Okay. All right. What about number 6? From a point 20 feet from a house, the angles of elevation from the base of the chimney to the top of the chimney are 37 degrees and 45 degrees, respectively. Find the height of the chimney. This is all about the sketch. All right, so I'm going to draw a house. Pretty sweet house here. Look at this house. Man, $1 million. All right, so there's the chimney. All right, yep, smoke's coming out of the chimney. It's doing great. All right, so what we're saying is that there is a point that is 20 feet from the base of this house. 20 feet from the base of the house. Such that the angle of elevation from this point to the bottom of the chimney is 37 degrees. From the same point to the top of the chimney is 45 degrees. What's the height of the chimney? All right, so here's the deal. Could we draw in a triangle, this red one, with that 37-degree reference angle, and figure out why? Okay, now looking at the green, could we do the same thing in green? That whole thing was x. What's the height of the chimney going to be? X minus y. So I would encourage you to do this separately. This is 20, 45 degrees. You know pretty quickly that's going to be 20, right? Do we know how to find the other one? All right, I don't remember what that is, but hold on one second, guys, 1 second.